Welcome to the last week of the semester, final chapter. Let's see, so yeah, we're on the final chapter. There is no final for this class, so you can use next week to catch up on your work. Let's see. Let's jump to Zybooks chapter 12. Let me make sure I'm recording. Yep, I'm recording. Okay, so chapter 12 is about files. So up until now, we've been passing input into our programs using keyboard input, just using the input function. So now we're gonna use the built-in open function. Okay, so basically, here, let's look through this. Okay, so Python has very simple built-in functions to open a file and to read a file. Okay, so let's skip down a little. Okay, let's get to this challenge. So, like I explained before, you can try to learn everything before you start something, or sometimes it's easier just to try it and then look back to reference what you need to do. So we'll go from the bottom up. So let's start this challenge. Okay, so in this challenge, a file's name is read from input. The file is opened and leak file is assigned with the file object. Okay. Each line in leak file contains a name and an integer representing a customer's name and the number of leaks the person has. Complete the assignment of leak data by reading leak file's contents as a string. Okay, so let's look at an example here. So this is the input file, data1.txt, and this is what it's going to print. Basically, the file exactly as it's shown. So here, this is the Python script that we're going to modify. So we're not going to do any error checking here, but basically we're grabbing string input and we're using that as the file name. And it's going to open the file that, with the same name that you type in. So obviously there's no error checking here or anything like that. So it's, for this exercise, we're going to assume that you're going to put in a valid file name there. It's going to open it, and this leak file is the Python reference to that file. Okay. So it's going to open it, and when it's done, it's going to close it, and it's going to print leak data. So all we want to do is assign leak data, right? So if we look earlier on, we can see the .read function, right? This reads the text file into a string. And that is what we want to do. So, oops. Call the .read from leak file. Okay, so let's look. This is in data1, data2, data3. Okay, so now if we check this, Okay, I got an error again. Let's try again. Okay, there we go. Oh, okay, didn't like this being on the same line here. Okay, so that worked. So this very simple example, it's just doing a direct read and printing out. So it does match the actual contents of the file. Okay. So now let's go to writing a file. Okay, so the most simple method is file.write and writes a string to a file. So in this example here, we're doing an open, and let's go over what this is. There's another parameter, you know, with the string W. So we can assume that's probably means we're going to open this file for writing, right? Then we're going to do a write and close. So right on cue, here it is. So this is the modes for opening files. So R is open file only for reading. So allows read, no writing, no creating a missing file, and no overwriting a file. Okay. W is open the file for writing. So if the file doesn't exist, the file is created. So that's what's here. Create missing file. And obviously we're going to allow write, and we're going to allow an overwrite. Right. So the difference between the overwrite W and A is for appending. So when you're appending, it's going to behave just like the write. It's going to create missing, and it's going to allow a write, but it won't allow an overwrite. It's only going to add to the end of the file. Okay. So something like this is very useful if you're going to write log output. Right. Okay. So let's see. Okay, and there's some modifiers like the plus. Specifying update mode allows for both reading and writing of the file at the same time. Okay, and then this is key here, the output buffer. So anytime you're writing to a file, no matter what program you're using, what language you're using, it naturally does some sort of buffering before it actually writes to the disk. So by default in Python, its data is line buffered. So that means like here, once you have a new line character, then it'll write to the file. So it's not going to write each character at a time. Okay. So where this is important is, let's say while your program is executing, you're going to check the output file, right? What's written to the output file doesn't necessarily correspond to where it is in the program execution, because it might be not, the program might not have completed finishing a line before it writes it out. So that's something to keep in mind. So that can be controlled. If you don't like the default behavior, you can control, how the buffer is going to behave, right? So that would be application dependent, where, you might want to override it or force a write with a flush. Okay. You might want to, for performance, you might not want to be flushing it, but if you're debugging, you might put in a flush to see what's happening so that you can debug. And then you can remove the flush after you're done writing the program for best performance. Okay, so let's get to the first challenge. Okay, file name shoppers data and value one shopper value are read from input. Perform the following tasks. So open the file shoppers data for writing and assign shoppers file with the open file. Okay, so shoppers data is a string of the file name. Okay, and we're going to create shoppers file, which would be the Python reference to that file. Okay, then write one shopper value followed by a new line to shopper's file. Okay, so one shopper's value is another string input that we're getting. We're going to write that and overwrite any existing contents. And then we're going to close the shopper's file. Okay. So first thing we're going to do is open the file. Let's see. Just open. Okay. And we're going to use shoppers data as the file name. Okay. Then let's in the close in the middle. Okay, so we're gonna do shoppers file dot write. We're gonna do on shopper value. And then we're gonna close it. Okay, so let's check this. It does say followed by new line. So let's see if new line is implied with this write. Okay, so we got an error. Oh, okay, this is the first problem. I didn't specify that it's we're opening in write mode. So let's try that again. Okay, now this time everything matches, but the new line is not implied. So we need to supply the new line. Okay. So what would be a good way to supply the new line, right? So we wanna supply this /n. So we'll just do another write. For problem again. Okay, let's try again. Okay, this time everything passes. We got the new line that was expected. So the write function doesn't imply a new line. You know, like if you did a print to screen, the new line is implied. We're doing a write to supply it here. You can also concatenate to the string before you write it out. You know, there's many ways to do that. Okay, so here, the lessons that we learned in this challenge is, yes, you need to pay attention to the file mode, and you need to pay attention to whether new lines should be put in or not when you're outputting files. So if we had many shopper values, then if we didn't put the new line, and we kept doing the write, they would all end up on the same line in the file. Okay, so that's writing. Says the robots have won. Let's try refreshing. Okay, let's try again. Back to file systems. Okay. Seems like Zybox is having an issue today. Okay, so interacting with file systems. Okay. So a program needs to interact with the computer's file system to get the size of a file or open a file in a different directory. Okay, so what we've done so far with the read and write, we don't have any path attached, so we're assuming the file's in the same directory. The computer's operating system, such as Windows or Mac OS, controls the file system, and a program must use functions supplied by the operating system to interact with the files. The Python standard library's OS module provides an interface to the operating system function calls and is thus a critical piece of the Python programmer's toolbox. Okay, so you're not calling the operating system functions directly. The OS module is giving you the interface to that. Okay, so let's look at this example here. So we're going to import the module. We're going to open this file for read. I'm going to call the os.stat function. Okay, and then we're going to call os remove, and that's going to delete that file. Okay, so this is a key paragraph right here. Right? Programmers should consider the portability of a program across different operating systems. You want it to behave the same way across several instead of maybe just your Windows or just your Mac, right? So one example is the what do they call it? The path separator, right? So on a Mac and any Unix system, it's a // On Windows, it's a backslash. Okay, so a common error is to reduce a program's portability by hard coding file paths as string literals with operator-specific path separators. Okay, so to help reduce such errors, good practice is to use the os.path module, which contains portable functions for handling file paths. Okay. So here, to get a proper path, so if we're going to do subdirectory batmobile.jpg, if you did this would work in Windows, but not on a Mac. And then, and just so you know, the reason there's two backslashes is because backslash is a reserved character. So it's used to escape for escape characters. So if you put two of them, then you're escaping it into one backslash. Okay. So instead, you can use os path.join, put in all the directories, and on Windows, it'll create this, and on Linux and Mac, it'll create that. Okay. So basically, when you install Python, the Python that's installed, the OS path, the OS library, uh, is basically when the OS library executes, it detects what platform you're on and gives you the appropriate. Okay. Okay. So this path it's going to be critical because for the most part, when you're dealing with files, it's not going to be in your directory, right? Uh, so let's look at some of the other functions. So os path.split. Okay. So if you did a os path.join, you would get all this. So we're joining all of that. And if we did a split, this is giving the last token. So everything and the last token. So that's why it's giving the entire path and then the last token. So where that's useful is basically it tells you the first part is a directory and the second part is a file name. Okay. Exists. You might want to, most of your programs, you want to check before you do a file operation, you want to check if that file already exists or not, right? Okay. Is file is also useful. Tells you whether it's a file or it could be a directory. So you want to know that it's a file if you're going to write to it. Get size returns it's the path.get size. So it's returning the size of the path, size of the file. Okay, let's see if there's a challenge here. No challenge here. This is an interesting function, os.walk, right? So this walks a directory tree. So if you had a directory tree like this, it basically goes through every single item in the path. And then there's an example here. So when you do a walk on the path, you can put it in a for loop and print it out. So that's what we got here. Binary data. Okay, so up till now we've only been dealing with string data, whether it be mostly with user input, and then now we did some files with string data. So binary data is a little different. Okay, so they're not necessarily readable characters. Okay, so let's look at the first piece of code here. So my bytes. So we're assigning a byte binary data literal into my bytes. then we're gonna print it, and then we're gonna get the type. And this will be the output. So this is the type, class bytes. Then this is the string literal that it prints. Yeah. And then this is an interesting example. So we're printing that, and then see, we're escaping to the ASCII characters here. So these correspond to 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the output there. And then the B is another modifier when you open the file. Then here's a, if you ever get to it, here's a key distinction. So in Windows, new lines are carriage return, then new line. Everything else is just a new line. So when you're doing things in binary mode on a Windows computer, the new lines in the file are not mapped to carriage return new line. So Python does some of that translation when you're dealing with characters, but when you're in binary mode, it leaves everything literal exactly as it is. Okay. There's a challenge here. No challenge here. So there's not a good simple thing you can do with binary files. So I would say just run through the participations on here, look through the code. Okay, so this is an important section. Command line arguments and files. The location of an input file or output file may not be known before writing a program. Instead, a program can use command line arguments to allow the user to specify the location. Okay, so assume two text files exist named myfile1, myfile2. Okay, the sample output shows the result when executing the program for either input file and for an input file that does not exist. Okay, so no problem with myfile1, myfile2. Myfile3 doesn't exist. Okay, so if we look at this code here, first thing we're checking is the if you remember sysargv is all the command line arguments. We're checking the length of that because we want it to be 2. The first argument is always the name of the Python program. So it'd be my script py. The second value is the first user supplied argument. So we want to check that if it's 2, and if it's not 2, we're going to print an error message to tell the user, we're giving the user help. It should be sysargv0. That's the first one. So we're giving them back the clue that that's the Python program, and then you should supply one argument with input file. The sys.exit, this is a So if we're getting this error, we're going to exit the program right away, and we can supply it an exit code. So in general, an exit code of 0 means there's no errors. Anything non-zero means that there is an error. So sometimes you'll use this when you execute programs, you'll check the exit code to see if you should continue on. Right? You can do that in Unix shell scripts. Okay. So next, if we pass this check, we're going to get argv1, which is a file name. Right? And then we're going to open that. So before opening, we're going to do a check, see if that file exists. If it doesn't exist, then we do a exit code 1. Okay. What you can also do is these are two different kinds of errors. So it's arbitrary what you assign the exit code. The convention is anything non-zero means it was not successful. So you can put a 2 here, let's say. Then if you have a shell script that's calling this program, it can act accordingly based on whether it got a 1 or a 2. Okay. Okay. So the way this program is laid out is it's checking for error. If there's an error, it exits immediately, checks for the next error. If it, then exits immediately if there is an error. So that means if it made it to here, it cleared that. So now it's going to do the open in read-only mode. Okay. And it's going to read 2 integers. It's going to do a read line. Okay. So that's different from the read. If you recall, the read read the entire file. Read line will read it the up to the end of line. And that's where it could be a carriage return new line or a new line. And Python will translate that into a single line for you between Windows and non-Windows. Okay. And in the read line, it'll remove the new line character. And then now we're gonna close the file. Then we're gonna print num1, num2, and the sum. No challenge for this section either. Okay. Get to this. Yeah, having Zybook's connectivity issues today. Okay. Yeah, I just want to go back to this code really quick. So in this case, you can see that we're doing all these error checking and then continuing on. So we have the full logic here. If you remember back in the previous chapters, you can also handle this with the exception handling, right? So you could put the open in a try block, you know, and then handle the error that way. It's the other check. Yeah, so it would be the open and the read line. You might want to put that in a try block because we're doing 2 reads and the file might not have 2 lines, so those are things you can put in a try block. Okay, back to the with statement. Okay, so this is a shortcut that lets you quickly execute a block of statements on a file and close it. Okay, so we're going to open my file txt as a read. It's going to be assigned to my file as the object. And then you can execute statements there. Okay, so we're going to open a file for reading and appending here with open as we're just using the letter F. So I'm going to read, create the product. We're going to write a new line. Then we're going to change the product to a string and write that out. And we don't need to close anything because this statement will close the file as soon as it's done. Okay, and now our last section, CSV files. Okay, so a CSV file is a very commonly used file format. Anytime you have a spreadsheet type data, any sort of table, a CSV is considered the most portable way to pass that around. And yeah, it's comma separated values. So every value is separated by a comma. So the line delimiter is a new line and the column delimiter is the comma. So this section just gives you an example of how some of the Python functions you can use to process a CSV. So in this case, we're going to open a CSV. And we're using CSV reader. And we're supplying the delimiter as a comma. Right? So a delimited file like this is common. It's not necessarily always a comma. So you can supply any delimiter that you want. Right? Sometimes people will still call it a CSV, even if something else is delimiting it, just because it's a common word to use. But a lot of times, if people would use a special character for the delimiter, like maybe the pipe character, right? The pipe, which is the shift backslash, right? So if you use a character like that, then you can have more general text in between because you might have data that has commas in it. So let's say you had last name, comma, first name, and you might want that as one field and not necessarily two fields. So if you use a special character like the pipe that doesn't appear in your data otherwise, then it'll make things easier. You can see in everything can be fully expressed in a CSV because you can do things like putting it in quotes. So like this, little Peter is put in quotes. So this is considered one field, even with a comma separated, because it's in quotes, right? And here's an example here where they use semicolons so that this stays one field. So there's several ways to do it. So basically the CSV module gives you many methods to help with that. So I don't think, yeah, no challenge on here either. So let's look at this reading here. Okay, so we're doing an import CSV module, and we're using CSV reader, and we're doing this file that we read in, CSV file. We're passing the delimiter. And this row num1 and this increment, this is just for this part of the printing. But all we're really doing is we're going to iterate over grades reader, and we're going to print each row. So it's basically, it's a list for every row. So every time grades reader has 4 rows, and each row is a list. Okay, let's look at writing rows to a CSV. So in this case, we're using CSV writer, right? And we're doing a write row, and row 1 is this list. Row 2 is this list. Okay, so that takes us to the end. Any questions? Okay. So we can just look at this lab real quick. This is an optional lab. Let's see. Quite good involved. So let's see what this lab is about. Write a program that first reads in the name of an input file. Okay, then reads the input file using the read lines method. The input file contains an unsorted list of number of seasons followed by the corresponding TV show. Your program should put the contents of the input file into a dictionary where the number of seasons are the key and the list of shows are the values, since multiple shows could have the same number of seasons. Okay. Sort the dictionary by key, greatest to least, and output the results to a file named outputkeys.txt. Separate TV shows associated with the same key with a semicolon. Next, sort the dictionary by values in reverse alphabetic order. Okay, so this is a very involved lab. Okay, so you can see right here, it's doing number of seasons in reverse order, right? So 30 seasons is The Simpsons. 20, there's 2 of them, Gunsmoke, Law and Order. And oh yeah, this is one show. There's just a comma in it, right? So it's to create that output, and then after that, the output titles will be reverse sorted based on the name. So we're gonna get the unique list of all shows and write it out like that. Okay, so we're not gonna do all of that, but we can do some, we can just do some read lines. looking to maybe show the solution, but I don't see one here. Okay, but first thing we're gonna do is we're gonna read the name of an input file, then reads the input file. Okay. So we'll do a simple open. Okay. Using the read lines methods. Okay. We did that, we would just be reading the first line, right? So we'd be reading 20, then we want to read Gunsmoke. So what we really want to do is we want to read all the lines in the file and then save it into a list and such and such. But let's just try this. Okay, so let's look up read line. Read line module. So we want the okay. Let's just try a file read line. There we go. Okay, does that, does that. All methods. Okay, so read line returns one line. Read lines will return a list of lines from the file. Okay. Let's just do something simple here. Okay, then now we're going to output two different files, right? Put keys. Here, let's look for the right. Let's open it in a pen mode for us. Okay. So we're going to read a line. We're going to write it to output keys. Then we're going to read another line, and we're going to write this to output titles. Yes. Yeah, it's going to read that from an input. So it's going to be user input will be file1 txt. So it's going to take the user input and then open that file. Okay. Yeah, so that's how it'll read the input file. And then now we're uh we're not doing what this is saying. I'm just gonna alternate and then write two different files, just so we can see what's going on. You know what? I should not have used the word in. Yeah. I think I need to oh, it's just open. It's not file.open. Let's go back here. This is where I supply the input file1.txt. And see what's in the files. And do this. Close. Let's close all of the files. Reopen them for read and then just print them out.
Open files are on.
So we did an append. So we did A for append. So we're writing to the output files, right? So now I'm just gonna open them for reading, right? And then I'm gonna say keys equals I'm gonna read the whole thing. I'm gonna print keys. Send back after. Oh, um, okay. So I opened it. I did a series of read lines. So I got some keys. Then I put the titles into the titles file, and I'm reprinting them out. So this is what we get. Yeah. Since I'm appending it, that's why we got double of each. So if I run it again, I think we'll get triple. Yeah, so now we got triple. So since we're doing the append. Okay, so let's look at your real labs. It's probably not as complicated as that optional lab. But yeah, so in the labs, these labs will be a little more tedious because you have to do a lot of processing with what you're reading in. Okay, if there's no other questions, then you made it to the end of the semester. You have an extra week to catch up with any work.